So this session will be on definite integration, indefinite to definite by the help of fundamental theorem of integral calculus. We learn the topic, we solve several sums here in the class. Then you will be practicing sums with me in the class. Okay. What is definite integration? In definite integration, we integrate within limits. Okay. Definite integration means integration within limits. That is definite integration. Within limits, why? Because now this class I will be discussing what is included in your CBSE syllabus. Only will go in accordance with the syllabus. So in CBSE syllabus, the meaning of definite integration as limit of sum is now excluded. So don't be confused why I am taking name of that topic which is excluded, because some of you might be following the older edition of NCERT or exemplar book. You will see some problems based on the meaning of definite integration as limit of sum. For CBSE class 12 board syllabus, we don't need the concept of definite integration as limit of sum. Summation of infinite series also can be done with the help of definite integration as limit of sum, which I have explained in one of the previous session here, and that is required for JEE only. But today's class, you try to understand what is included in your CBSE syllabus. I will be sharing the topic what exactly NCERT published in their website, that is what is the syllabus on definite integration. We'll learn it first. Okay. So what is included over there in syllabus? Fundamental theorem of calculus without proof, basic properties of definite integration, and evaluation of definite integration. Only this thing is there in syllabus. There is no point of confusion. Clearly mention this topic. Fundamental theorem of calculus means integral calculus without proof. No proof is required for board. And basic properties of definite integral and evaluation of definite integral. Okay. So although I am not going to represent definite integration as at this moment, definite integration as area or as the limit of sum, but the fundamental theorem of integral calculus, which is included in your syllabus, is partly based on that. Okay, we can learn it without knowing in details about it. I am going to define a term that is called area function. Let me define the term area function. What is the area function? Try to understand. Geometrical meaning of definite integration states that when we integrate between 2 points A and B, the function y equal to fx, y equal to fx is the function when you integrate within limits. These are 2 points. This is A0 and this one B0. Then A to B fx dx, function is obviously continuous. Without continuity of function you cannot do it. This A to B fx dx will represent area under the curve with x axis. Which area? This area. This area with x-axis is the area under the curve. Okay. This area. This you don't take AB because already you have taken that. So you name this one as LM. So area of A to B fx dx, area under the curve x-axis, it is given by this. If we evaluate the integral within limits, then we get the area. Then where does the concept of area of function arise? See, here the interval is A to B. Instead, we consider A to B interval. Let us take the interval from A to X. Consider A to X and this portion area. According to this definition, how to find area of this portion? APLR. How to write this area? APLR. That area of APRL is by this definition. See, A to B fx dx equal to area. So area of ARPL, here it is going to be A to X fx dx. The function is fx, it is A to X fx dx. Now, this is a function of x. If we evaluate this value, we will be getting a function of x. So, why this one is a function? As x is increasing, the value of area also increasing. Okay? Either increasing or decreasing, I mean there is a relationship between the variable x and this function ax. That's why we will refer this one as a function. This is called area function in calculus. Now for this area function A to X fx dx, we can state fundamental theorem of integral calculus statement 1. So we are going to do fundamental theorem of integral calculus. I will be telling you the way it is stated in your textbooks. I will just explain the meaning, everything written over there. So what will be that? Let Ax equal to A to X fx dx. Without proof, first fundamental theorem of integral calculus states that area function's derivative is equal to fx. Okay, this is actually a version of Leibniz rule, but you don't have the scope to discuss today's class. Leibniz rule we are not going to do. That we will do when exclusively you are doing for JEE exams. So by fundamental theorem of integral calculus, A dash x will be equal to fx. This is first fundamental theorem. Okay. For example, suppose we have, let Ax equal to 3 to x plus 2 dx. Okay, this is area function. If you integrate between the limits 3 to x, you get the area of this function. I mean area of the function y equal to fx. What is fx here? We have taken fx equal to x plus 2. Then A dash x will be equal to x plus 2. You will not find many application of this in your textbook on this, but this is a topic for JEE Main. many integration problems in JEE papers, JEE main papers can be solved with the help of this first fundamental theorem of integral calculus. If it arises in your board paper, then you come to know how to write its value. Derivative of this thing is x plus 2. Some calculations may be there based on it. I can state one problem like this. Let area function be ax equal to 0 to x 3x plus 1 by 4 dx. Find a dash x at x equal to 1. This is not a JEE sum. Just to know how to find the derivative of the function. You will proceed the way I told you. What is that? You will write by first fundamental theorem of integral calculus by FTIC, a dash x is 3x plus 1 by 4. So what they asked? Find the value of a dash x at x equal to 1. So a dash 1 will be 3 into 1 plus 1 by 4. Answer is 1. Clear? We got the value of a dash 1. That is derivative of area function at x equal to 1. In board paper, you can expect this kind of questions. Okay? Not much application, not many applications will be able to find now. Definitely I will give you questions based on it. And then what is second fundamental theorem of integral calculus? We will write second fundamental theorem. Second fundamental theorem of integral calculus. What is that? Suppose there be a function, let y equal to fx be continuous in AB. Y equal to fx is a continuous function in this interval. Okay? Continuous in AB means that is for all x belongs to AB, y equal to fx is continuous. Now let primitive of fx be phi x. What is the meaning of primitive of fx? That phi x is actually antiderivative of fx. What does it mean? F dash x is equal to phi x. No. Just opposite. Fx equal to phi dash x. Then phi x is said to be antiderivative. Then fx dx a to b will be equal to phi a. Without knowing this theorem, you found many applications if you have studied physics, chemistry or economics. And this is without proof. Okay, this fundamental theorem of integral calculus second statement is what? If they have asked you to integrate say x cube dx, one to do. You have to find a function whose derivative is this function, isn't it? Whose derivative is this? that is integration of this. What is integration of x cube? x4 by 4, 1 to 2. 16 by 4 minus 1 by 4. So we are putting upper limit, that minus lower limit. This is the concept. This we have used finding work in physics, isn't it? Work done by a force to move a body from one point to another point, x equal to 1 to x equal to 3 meter, we have integrated. So fundamental theorem of integral calculus, we will be doing this one now, and we will be revising whole of integral calculus with the help of this theorem. Main part is the integration part, then simply put upper limit minus lower limit. Sometimes we will do it by substitution, sometimes we will do without substitution. Okay? Let us see this one. Look at the sum here. You do it with me. Better you finish it before I do it here. 0 to 2 dx by this thing. I have taken many sums so that whole of integration you can remember now. How to integrate this one is a question now. Root x plus 3 minus root x plus 1. We need to rationalize the denominator, isn't it? So this is going to be x plus 3 minus x plus 1 dx. We have multiplied numerator and denominator by multiplying inner and dr by root x plus 3 plus root x plus 1. Now x get cancelled. So half is a constant, it will come outside. X plus 3 to the power half, x plus 1 to the power half dx. Half, this is what? Alright. So this thing going to be 1/3. Put x equal to 2 over there. 5 to the power 3 by 2. 3 to the power 3 by 2 minus, then upper lower limit x equal to 0. It is 3 to the power 3 by 2 minus 1 to the power 3 by 2. Understood? Putting x equal to 2, this 3 by 2 is common over there. So you take this thing outside. Outside it will come like this. It is simply x plus 3 to the power 3 by 2, x plus 1 to the power 3 by 2, and then 0 to 2. Upper limit you will put overall in the whole function. 2 plus 3 is 5. 5 to the power 3 by 2. 2 plus 1 is 3. 3 to the power 3 by 2 minus, put x equal to 0. 3 to the power 3 by 2 and 1 to the power 3 by 2. Clear? You simplify or not, it doesn't matter. Just check that this term and this term getting cancelled. 5 to the power 3 by 2 is 5 root 5. 1 to the power 3 by 2 is 1. Clear? Understood? Go for next one. I have already shared with you. Try to do the next problem. Before I do it here, this one 0 to pi cos square x dx. Everyone knows how to integrate. How to? Multiply by 2 and divide also. 2 cos square x you know. 1 plus cos 2x dx. Put upper limit pi plus cos 2 pi and then lower limit. Oh my god, this we have to integrate first, no? Without integration we cannot do it. Integration not done only. Integration of 1 is what? X sin 2x by 2 0 to pi. Alright? Put upper limit pi plus sin 0 plus sin 0 by 2. Okay? So it is half into pi, bus, finished, because sin 2 pi 0, sin 0 is also 0. So answer is pi by 2. Okay? Clear? Done? Go for next problem. Minus a to a x root over a square minus x square dx. How to do it? You can make a substitution or you don't make. You can make a substitution. What substitution? Let x equal to a sin theta. This I will show you how limit should be changed when the integrand is changed in terms of another variable. We have taken x equal to a sin theta. For x equal to a, therefore sin theta equal to 1. So theta is what? Pi by 2. And another limit is minus a. For x equal to minus a sin theta is minus pi by 4. Limit is changed. So once you change the limit, the whole integrand should be written in terms of new variable a sin theta, and this is what? A square, isn't it? And what is dx? A cos theta d theta. That is the value of dx. A cos theta d theta. Understand? Just differentiate. So put it here. And what is the limit of integration? For minus a, it is minus pi by 4. Check once my calculation whether correct or wrong. We have taken x equal to a sin theta, dx equal to a cos theta d theta. We are putting there. But same limit cannot be continued. This will be pi by 4, no, pi by 2, sorry. By mistake. It is minus pi by 2 to pi by 2. So this is minus pi by 2 to pi by 2. A sin theta, a cos theta, isn't it? So this is changed to what? Take a cube outside. Minus pi by 2 to pi by 2 cos square theta into sin theta. Now what to do? Sum is more complicated. You could have taken a square minus x square equal to z square. It could be easier for you. But as you have taken this thing, I can change it in this manner. No more substitution. You write a cube by 2 multiplying 2 by 2. 2 cos square theta is what? Isn't it? This is okay? Now multiply a cube by 2, open the bracket. This is what? Sin theta plus isn't it? So integrate this, you can write a cube by 2 outside. Sin theta integration you do separately. And second one you write a cube by 4 2 sin theta cos 2 theta. That is 2 sin A cos B is what? 2 sin A cos B is what? Sin A plus B plus sin A minus B. Minus if you write, then change you have to do here. Sin A plus B minus sin, isn't it? This is correct, no? This only you are trying to say. Now put upper limit over there. Minus cos pi by 2 0 plus 0. Finished. But this one, let's see what happens. We'll be integrating this part. Sin 3 theta. What's the integration? Minus cos 3 theta by 3, and it is okay. So 0 a cube by 4 cos 3 pi by 2, that is 0, cos pi by 2 0. This minus again it is 0, this is also 0. So answer going to be what? 0 only. Clear? Answer to this integrand is 0. Go through the next one. Sin to the power 4. I think this manipulation you can do it. You will practice just after my turn. Check next one. And I suggest you make the substitution and change the limit. That you must do. Substitution is quite obvious to indicate this in indefinite. What you have done? You have taken log x at z or 1 plus log x at z as your convenience. Then change all the limits and then integrate. Okay? You do before I complete here. Practice with me. Just let 1 plus log x equal to z. You let 1 plus log x equal to z. So differentiating Alright. The z by z square and limit of integration 0 to 2. All of you know this. Log 1 is what? 0 and log a is 1. That's why 1 plus 1 in the second case is changed to 2. Now this integration you know. It is minus 1 by z. So one thing, is this limit valid over there? 1 to e we are doing it. Here limit of integration, oh it was my mistake, that's why. It will be 1 to 2, isn't it? Log 1 is 0 but 1 is there. It will be 1 to 2. So upper limit you put minus 1 by 2 minus lower limit. Concept is clear. 1 minus half value is 1 by 2. Okay. Go for next one. Already the document shared with you. This sum. X dx by root over a square minus x square. Again you make substitution and change the limit. That is always better. You can put trigonometric substitution, you can put algebraic substitution also. Algebraically, let me do it. Let a square minus x square equal to z square. You agree? To remove the square root, we can do it. Differentiating both sides. Minus 2x dx equal to 2z dz. So minus x dx equal to z dz. So put it there. When x equal to 0, z equal to what? Z square is a square, z equal to plus minus a, we will take plus. And when x equal to a, z is equal to 0. So this will be a to 0 minus z dz by this is z. Get cancelled. Okay. Just this sum I did. Again, how to change the limits of definite integration. But most of the students, what they do, at least for their first school examination on this, they integrate and use the old limits only. Definitely they go wrong. Only some step marking 0.5 or 1 can be given. Go for next one. Sin square, I hope this one you can do. Sin square x, after my turn, you will start to do this one. Number 7 is your work. Number 8 is also your work. Number 9, sin x equal to z you put. Then you change the limit, your work. Tan 4 sec square x is very easy. Take tan x z. Then z4 dz, you can finish this also. Sec to the power 4x. Let me take a stop here. Take a break here. How to do it? Sec to the power 4x dx. If you don't remember, then I help you. You write sec square x. Indefinite part, I do the observation first. It is 1 plus sec square x plus tan square into sec square dx. Sec square x you easily write tan x. But how to do this one? Sec square x tan square x. You make a substitution tan x z. But I am not affecting the limit. I am doing indefinite part first. This is also your strategy. If you feel free, if it is more convenient for you, you do indefinite integration side and then put it there. The way I am doing here, integrand taken on right side. Now for this one, sec square x into tan square x, put tan x z. So after differentiation, what will you get? This implies that sec square x dx equal to dz. So this integrand will be z square dz. Tan x as it is, this is z cube by 3, isn't it? Integration z cube by 3. And it is tan cube x by 3. Okay, now put it there. This integrand changed to what? Tan x zero to pi by 4. Put our limit. There is 1 plus 1/3 minus 0. So the answer is 3 by 2. Clear? Understood the idea? Should change the limit or do indefinite part first and that you substitute on the left hand side. This is the concept. This one you will make a substitution sin x z and you will do accordingly. I am not doing it. After this session you will do. All these are trigonometric substitution. Here you put sin x z, then go by partial fraction. And for this one, put sin square x z. Let us do this one, part 14. Okay? We will be doing this sum right now. Yeah, this will be 1 by 3. This is, I wrote 1 by 3, but when I am calculating, I forgot. So this is 4 by 3. Answer is totally changed. 4 by 3. Go for this one. No, not this one. What I told, this one. It's a very interesting sum, but it's very easy. 0 to pi by 2 sin x cos x dx by 2 cos square x plus 3 sin square x. So I suggest you one thing, make the whole denominator equal to z, because in both the cases sin x cos x coming. That's why. Let 2 cos square x 3 sin square x equal to z. Clear? Now differentiate both sides. What do you get? 2 into 2 cos x minus sin x 3 into 2 sin x multiplied by cos x dx equal to dz. You understand? It's okay? So you take common now. This is what? 6 minus 4, that is 2 sin x cos x dx equal to dz. Therefore, sin x into cos x dx equal to dz by 2. Put it there. dz by 2 and this one z. But the problem is limit. Limit I did not change. If the variable change, limit has to be changed. How to? Just put it there. Put for x equal to 0, z equal to 2. And for x equal to pi by 2, z is equal to 3. Bas, done. 2 to 3. Isn't it? This one has integration log z 2 to 3. Clear? So put upper minus lower. So answer is half log 3 by 2 plus c. Clear? Oh, no c. Nobody told. No c will be there in definite integration, because when you do upper limit minus lower limit, that c get cancelled. So by mistake even never put plus c over there. External will deduct marks. This one I did not do. Put x plus 1 by x equal to z. This time you can write the substitution only. Next time you have to do it. This one, it is sine inverse. Please take care of this term. It is sine inverse root over x by a plus x dx. Dx is separate. Okay? Sine inverse of this whole thing is there. I told you, no, whole of indefinite will be revised here. How to do it? Let x equal to a tan square theta. Put it. X equal to a tan square theta. Text. Put x equal to a tan square theta, not x. Okay? Now try it first yourself. Check, it's a very important sum for your board examinations mainly. Put x equal to a tan square theta. So dx will be what? A into 2 tan theta sec square theta d theta for x equal to 0, tan square theta 0, tan theta 0, so theta equal to 0. And next one, the upper limit is what? X equal to a. For x equal to a, put it here. So tan square theta 1, tan theta plus minus 1, you will take positive value always. Okay? Because in this interval, when this function increasing this thing also, so you take pi by 2 only, not never negative. Huh? So I going to be what? 0 to pi by 2. What do you get here? X by a plus x on this substitution. We need the value of x by a plus x under root. So let us simplify it. The value of this thing will be a tan square theta. Tan square is sec square, it will be only, so square root will give you sin theta only. Understood? And dx part I have written here. 2a tan theta into sec square theta d theta. Clear? So this 2a will come out. Sin inverse sin theta is what? Theta. Now what? See, definite integration is very easy, but if you are good in indefinite, this integration how to do? What is the method of getting this? This important board exam only will use by parts, by taking theta as first and this whole thing as second. I am doing step by step. 2a, you can do indefinite part separately. You can carry the way I am doing here. This theta outside, tan theta into sec square theta, what is its integration? You can do it mentally. Tan theta equal to z. So this is dz. Z dz, z square by 2. Tan square theta by 2. Isn't it? Minus derivative of theta is what? 1 into tan square theta by 2 d theta. Clear? Here you put the limit. Alright? Oh my god, this is pi by 4, no? That's why I am getting something undefined. This is pi by 4, not pi by 2. You could have told me before. 10 by, it is 4, no? Zero to pi by 4. Upper limit, if you put tan pi by 4 is 1, so 1 by 2 minus the second part. How to integrate this? You write tan square as sec square theta minus 1. Isn't it? 2a half into this you write tan theta minus theta, then upper limit minus lower limit. 2a into tan pi by 4 is 1. Alright. So this is going to be what? 2a into pi by 8, pi by 8, pi by 4 minus half. Clear? Done? All these sums are based on by parts. I am not going to do. Just integrate by parts and then put upper limit minus lower limit. I will be solving those types. This one also, x square as first function, sin x as second function. Isn't it? Do after this session. How to do this one? Can you tell me? 2x tan inverse x, how to do? 2x into tan inverse x. Two is a constant, keep it outside. Then tan inverse x, integration of x is x square by 2. I am doing the indefinite part first. It may be problematic for you. Let me solve this part. 2 outside, tan inverse x first, x integration is x square by 2, understand, minus 1 by 1 plus x square. I hope you remember integration by parts. So x square tan inverse x, and numerator you write by x square plus 1 dx. Isn't it? Clear? So this is minus separate dx plus dx by x square plus 1. This one is integration of dx, this one tan inverse x. Plus tan inverse x. Once you get the result of integration, then it is just one step calculation. So I will be what? Upper limit 1 square 0 to 1, no, the limit is 0 to 1. Upper limit tan inverse 1 plus tan inverse 1 minus all are 0. So tan inverse 1, tan inverse 1. Tan inverse 1 is pi by 4. So answer is pi by 2 minus 1. Finished. Answer is pi by 2 minus 1. Okay. Done? This one you will try by taking log x equal to z. I am not going to do it. This is also very common sum. Just limits given. This one x by 1 plus sec x dx, how do you do? Zero to pi by 3, x by 1 plus, you will be taking x as first function and this one as second function and then proceed. If you don't get, report it to me. These are all, can be changed to standard integral. This one you will put x equal to sin theta and then proceed. Let me remind you these two sums. How to integrate this? Which formula is there? For first one, how to proceed? Evaluate the following integrals. This one you can change to standard integral, or you can make a substitution also. X equal to 2a sin theta. But standard integral will work nicely for this sum. How? You write it as 0 to 2a under root a square minus, you understand what I am doing? Zero to 2a under root okay. So this is of the form a square minus x square, standard integral of this form. You remember, you did it in by parts, plus a square by 2. Remember it. So I am just writing it here. This will be x, means x minus a this by 2 plus a square by 2 sine inverse, just 2 upper minus lower. Okay, just do the upper part minus lower part. Put x equal to 2a there, a, and this will be 0. A square by 2, 2a minus a by a, that is 1. Minus, if you put 0, then everything is 0. Sine inverse 1 you know, pi by 2, so pi square by 4. Okay? Sometimes we need to do mentally, no? We cannot increase number of steps to 20. So you just do mentally, put x equal to a and then put x equal to 0. Similarly, this one also you can change into standard integral, not going to do it. All these you can change into standard integral, then put upper limit minus lower limit. Now I have kept a different type of sum for you. Okay, this is on the concept of definite integration. Try to remember what I told you in this class. The definite integration nothing but area, and when you are using fundamental theorem of integral calculus 2, you need a continuous function. If function is not continuous, it will not be integrable. So question is here this way: find the error in the following solution, if any. Is there any error? Is the integrand this function continuous in the interval 0 to pi? No. Fx equal to sec square x is not continuous at x equal to pi by 2, sec pi by 2. So this calculation is wrong. Apparently it seems that it's true, but it is wrong actually. Clear? This one you try to make substitution and do. Try this one. Does a to b fx dx, a to b gx dx implies that fx equal to gx? Justify your answer. Let us think this manner. As I told you, definite integration is nothing but area. So for this function sin x, this area, and then cosine x, this, oh my god, yeah. This area, don't you think that they have the same value, same area, but they are representing different functions, sin x and cos x. Many you can set. Okay, just you find 0 to 2 pi sin x dx. This is for this curve, yellow one. What is the value? Minus cos x, 0 to 2 pi, no, 0 to pi, sorry. You just find 0 to pi sin x dx. Why? Because this part is 0 and this is pi. So put upper limit. So this is 1 and plus 1, 2. Clear? Now let us find for cosine curve minus pi by 2 to pi by 2. Although same interval they have given, no? Wait a minute. They have given the same interval. Interval you have to keep same. So you have to find answer that manner only, not this way. Here it is 0 to pi. For cosine x also 0 to pi. If you do, there is a problem here, no? Some part lying above, some part lying below. Isn't it? Magnitude of area will remain the same. If you say that, I will find 0 to pi cos x dx. This is actually 2 into 0 to pi by 2 cos x dx. See, same area will be there. Sin x pi by 2, 2 into pi by 2, 1, this is 2. But why it is 2 into 0 to pi by 2? Why? Because 0 to pi cos x when you are doing, actually it is representing this area, no? Area lying above x-axis, area lying below x-axis get cancelled. That's why I am making this one mod, or finding the area and adding that, or multiplying this area twice. Okay, find another algebraic one. If you are not happy with this, think about the algebraic problem here, where limit of integration, if you keep same, it will give us the same answer. In many problems you can set. You can play with all these. 0 to 1, let us find the value of 0 to 1 x cube dx. What is its value? x4 by 4, that is 1 by 4. Agree or not? Now let us find 1 by 0 to 1 x square x by 2 dx. What is its integration? Half outside, half into, they are not same. Functions are not same, but we got the value same. They told you to give the example that only, no? Here functions are, this is the right example. Previous one also, but you don't understand this part. So better you give this example. A to B, a document is with you, you can check it later also. This one you do. If ddx of fx equal to gx, then evaluate. I mean, for your board examination only, how much difficult question they can ask, because they have clearly mentioned it is fundamental theorem of integral calculus. And I found that there is application in this sum. So do it. This is okay or not? Ddx of fx equal to gx given, you have to evaluate this. See, this is a very simple question. You just make a substitution there. Let fx equal to z. Let fx equal to z. Differentiating with respect to z, with respect to x. Therefore, if dashed x dx but f dash x is what? Gx, isn't it? It is given over there. So gx dx equal to dz. Just put it there. Indefinite part if you do, then you will definitely change the limit. But here fx is z, gx dx is what? dz, z square by 2. Z is what? Fx. Fx whole square by 2. Just substitute there. So this integrand will be changed to fx whole square that divided by 2. That is fb square minus fs square by 2. Okay? Finished? This way. So today up to this, now you practice. Many more good sums are there in my collection. These sums are also there. How to do this one? Tell. 0 to pi by 2 sin x plus cos x by 9 plus 16 sin 2x. Sum is there in your textbook also. How to integrate this? I am helping this one. This is the last sum today's class. Then you will practice. So I am seeing one thing, that sin 2x we can write in the form of 2 sin x cos x. This is nothing but, isn't it, 1 minus sin x minus cos x whole square. Why I am writing this way? Our substitution will be easier for this sum if you write like this. You understand? This will be 0 to pi by 2 by sin x minus cos x whole square into dx. So this is basically indefinite integration sum, just given limit. Now how to integrate this? What substitution is required? Put I remind you change of limit again. What is this derivative? Cos x plus sin x dx equal to dz. When x equal to 0, z equal to minus 1. When x equal to pi by 2, z equal to 1. I hope now you can do it. Is this a standard integral? Obviously, you just take 16 common. That is just a one-step sum. 16 you take common. dz by, what is the integration of this? A square minus x square 1 by 2a log of am I correct? Minus 1 to 1. So you write. Now it's simplified. Just put upper limit minus lower limit. Okay.